Hi, I'm Chris with Sanderson Test Prep, and in this video we're going to take a look at a couple of principles that we see in physics in optics. So first I wanted to talk about magnification, and the equation for magnification is that magnification equals negative I over O. So let's talk about what that means. I is referring to our image, and O is referring to our object. And if we look at that as a ratio, then hopefully that makes some intuitive sense that if your image over your object as a ratio, ignoring the negative for right now, but just looking at it in absolute value terms, if your image is bigger, then that means that positive magnification has occurred, that the image that you are seeing appears larger than the object, similar to looking through a magnifying glass. And then if the image value that you have when referencing these image and object distances, if the image is smaller, well then that means that your object appears to have shrunken a little bit. So for your magnification, if your magnification is less than, and we want to look at this in terms of absolute value, so I'll say absolute value of magnification. If it's less than 1, think of that as a shrink in the size of your object. And if it's greater than 1, then think of that, it's a little big for the 1, and think of that as an expansion in your object, an increase in size. So that's what magnification means as far as an equation is concerned. Now let's see if we can incorporate the negative and understand how that impacts the meaning behind this equation. So for this, if we look at negative I over O, let's talk about what that would mean for whatever our final value is. So for your final value for magnification, if magnification equals negative 2, or if magnification equals positive 1/3, or if magnification equals a positive 1, or if magnification equals a negative 2/5. So let's talk about what some of these values mean. And you'll see two terms associated with this value for magnification. You'll have objects that will appear either upright or inverted. And that has to do with the positive or negative sign. So when we're looking at this idea of an object that will appear upright or an object that will appear inverted, that all has to do with the sign. Doesn't matter about the numerical value, but it's the sign of your magnification. And for M, if you had to guess, if M is positive, would you guess that that means upright or inverted? So again here, this is one that sometimes makes intuitive sense if we really think about it. A positive value for magnification means that you're going to have an upright image. And a negative value means your image would be flipped. It'll be upside down from the original object. So here, this one would be inverted for the first one. This would be upright for the next one, upright for the next one, and inverted for the last one. So all we care about for upright versus inverted is the sign that we have. It's going to be a positive or a negative. Now, if we want to know if these are expansions in terms of the size of the image compared to the object, let's take a look at that here. So for the first one, we have a value of 2, and even though magnification is a negative, the absolute value would be 2, which is greater than 1. So this would be an expansion for that first one. The second one would be a shrink. The third one, if it's equal to 1, what do we think that means about the image in the object? Expansion or shrink? So hopefully you recognize that that's a little bit of a tricky one, and there's actually not going to be an expansion or a shrink in the actual size of the image compared to the object. They will be the exact same size. It'll be to scale. And this would be something that you would see on a plane mirror, kind of like if you are brushing your teeth in the morning, you look in the mirror in your bathroom, then that's going to be a magnification of 1. We don't want to appear larger or smaller to have that distortion in that image. And then the last one would be a shrink, 2/5. Again, absolute value is less than 1, and therefore we have a smaller image as compared to our object. For more, please stay tuned to our other videos, and thanks for watching.